learning. Good morning to all. Yesterday we have done few problems on modulus function. Now we'll do few more problems on it. Just look at this. Solve modulus of x minus 3 plus modulus of x minus 2 is equal to 1. Modulus of x minus 3 plus modulus of x minus 2 is equal to 1. Now you just look at here. This modulus of x minus 3 plus modulus of x minus 2 value is what? 1. So try to write down this 1 in terms of these two, x minus 3 and x minus 2. Try to write down this 1 as in terms of what? X minus 3 and x minus 2. How I will write here? Can I write down this as 3 minus x in terms of these two only? 3 minus x plus what? X minus 2. Satisfied on it. This 3 minus x can also be written as what? Minus of x minus 2 plus x minus 2 or this 3 minus x, if I take minus common, I am getting minus of x minus 3 plus x minus 2. So finally I have written this and this like this, so that we should get the value is what here? 1. So that implies what happened? This modulus of x minus 3 I written as what? Minus of x minus 3. So that means what? X minus 3 is a less than or equal to 0. Plus is there. That's why you write a and. Why? These two are changed or not. Simultaneously I changed this one and this one. But this one what happened? No change on it. Inside the modulus whatever is there, the same I got here. So what does it mean? This is gives x minus 2 is greater than or equal to 0. Combining of these two, whenever and is there, we have to take a commonality on it. It implies what? X less than or equal to 3 and 2 shifted to that side, x greater than or equal to 2 on. It implies what? Combined these two, one is less than or equal to 3, another one is greater than or equal to 2. The commonality of these two is gives what? X lies between 2 to 3 on. So greater than or equal to 3 if we draw the number line like this, 2 lines to take it. One is what? X less than or equal to 3. This is a 3. X less than or equal to 3 means this part only. This is 3. This is a 2. But x greater than or equal to means which part? This part only. Then what is your commonality here? 2 to 3 is your commonality only. This is a less than 3 or equal to 3. This is greater than or equal to. What is the common shaded part here? What is the common shaded part here? The common shaded part is from 2 to 3 on. Next one you see here. Next question, number 2. Modulus of x minus 3 minus of modulus of x minus 2 is equal to what? 1. Modulus of x minus 3 minus modulus of x minus 2 is equal to what? 1. So to solve this equation, Better you write this 1 in terms of these two. What is that? I already told you. Can I write down this as a 3 minus x plus what? X minus 2 only. 3 minus x plus what? X minus 2. But this must write down as a difference or not. In between which sign is there here? Minus sign is there. That's why here also we need a minus sign or. In between which sign is there here? Minus sign is there. Here also we need a minus sign. That's why I'm writing 3 minus x should write in terms of x minus 3 or not. How? Minus of x minus 3. This also should write in terms of what? Minus sign here. Why? Because here we have a minus sign. There is a minus of x minus 2r. So now based on this, in between minus sign is there. I got here what I got here, minus of x minus 3. That means inside the modulus is a negative. Then only I can write minus of x minus 3 or not. So inside the modulus is what? Negative or 0 also we can take. I already told you. Either you can take a 0. Inside the modulus is a negative. I can take minus of inside the modulus. But this is a hold for negative or 0 also. For 0, here we get a 0, but here we get a minus 0. 0 minus 0 both same. That's why we can take a negative as well, 0 also consider here. So x minus 3 is what? Less than or equal to 0. And because these two must satisfy simultaneously or not. This modulus of x minus 2 also I got what? Minus of x minus 2. So what does it mean? It's inside maybe negative or 0. If you write it is as it is, so see, here I have written as it is or not. Here I have written as it is means what? Inside the modulus may be a positive or 0. Here I have written a minus of, this means what? Inside the modulus is maybe negative or 0. Right? If you write as it is, you can take inside is a positive or 0. If you write modulus as minus of inside the modulus, you can consider that inside is negative or 0. If inside the modulus is negative or 0, you write minus of inside the modulus. If inside the modulus is a positive or 0, you can write as it is. Inside the modulus is positive or 0, you can write as it is. Negative or 0, you can write minus of inside the modulus. So that's why this is also good. I have written minus or not. So that means inside the modulus is what? Negative or 0. Combining of these two, x less than or equal to 3 and what? X less than or equal to 2 or. Whenever the word and is there, you must take its commonality or. So that's why, look at here. 3, here 3 3 is what? Less than or equal to this. So where it moves? Minus infinity. Next here is what? 2. This is also less than or equal to 2. Where it, then what is your commonality you tell? This is your commonality or not? What is your commonality? This is your commonality. So therefore, x belongs to what? Minus infinite to 2 or not? X belongs to what? Minus infinite to 2. Or otherwise you can do one thing. What is the inequality here? less than or equal to type or not? What is the inequality here? Both the inequalities are which type? Less than or equal to type. When both the inequalities are less than or equal to type, then the common inequality also will get less than or equal to type or not. If both the inequalities are which type? Less than or equal to type, their common value also less than or equal to type or not. So that's why common value also you take less than or equal to type. Later you take a minimum of these two numbers. What is that? 3 comma 2 minimum. What is the minimum of 3 comma 2? 2. So that's why you got x less than or equal to 2 or not. For example, x is greater than or equal to 1 and x is greater than or equal to 4. But here inequality is a which type? Here inequality is which type? Greater than or equal to type. So if both the inequalities are here, inequalities are which type? Greater than or equal to type. If both the inequalities are greater than or equal to type, then the resultant also which type? Greater than or equal to type. But because of greater than or equal to type, here you must take a maximum of these two numbers. But here inequality is a less than or equal to type or not. That's why I am taking minimum of those two. Here the inequalities are greater than or equal to type. That's why the resultant also greater than or equal to type. But you must take maximum of these two or not. What is the maximum of these two? 4. Next see the third question. Question number 3. 0 less than mod x less than 2. 0 less than mod x less than 2. Solution see here. It is a mod x is obviously positive. That's why it may be greater than 0. So when modulus is a positive, you straight away you can take this as only mod x less than 2. No need to take this one. Why? Because mod x is always positive or not. Mod x is always positive or 0 also. But here 0 is not included. That's why mod x is always positive. No need to tell you. So now it implies what? As I already told you that it is look like a which form? Mod x less than a form or not. Therefore x lies between where to where? X lies between where to where I said? Minus a to plus a. Minus a less than x less than a. So that's why this is also can be written as what? Minus 2 less than 2. Minus 2 less than x less than 2. That is what. But from this what I have to do it? I want to delete a 0 or not. I want to delete a 0. Why? Here mod x is a greater than 0 or not. It never be a 0. When it is 0, whenever x is a 0, then only it is a 0 or not. That's why from this part you delete a 0. Finally, what happened your solution? Your solution set is x belongs to open interval minus 2 comma plus 2. Why here minus 2 plus 2? We know one add here. From this you must delete the element 0 or not. Why? Mod x is here, mod x is never equal to 0. The next one look at here, question number 4. Question number 4. Modulus of 3x minus 2 is less than 4. Modulus of 3x minus 2 less than 4. See here solution. While you are solving this one, let us consider this as x only. Let us consider this as x only. Let us consider this as x. That's why it is look like a which form? Mod x less than a form. Or then what is this formula? Minus a less than x. But x plus what is there? 3x minus 2 less than what? 4 or not. But the meaning of a solution here is just to find out a x range or not. Just to find out a x value. That's why add 2 on both sides. Add 2 on both sides. Then what happened? Minus 2 less than 3x less than what? 4 or sorry 4 plus 2 6. Later divide by 2. Later divide by 3. So you are dividing by a which number? Positive number or that. So inequality will not change. Minus 2 by 3 less than x less than 2. Therefore solution is what? X belongs to minus 2 by 3 comma 2. Now just we have to make use of the formula whatever I taught to you. First the problem is comparing into those forms. So after comparing to those forms, you write down its formula. Later you need only which value? X value or not. So that's why keep x alone. For that the remaining things, one time you added 2, another time you divide by 3. Because of divide by a positive value, inequality will not change. Got as it is. Similarly, you see 0 less than modulus of x minus 3 less than or equal to 5. See, while you are finding out of this solution, keep one point in your mind. As you aware of it, modulus of x minus 3 is always greater than or equal to 0. Modulus of modulus is always non-negative, maybe greater than 0 or equal to 0. But here 0 is not considered on. So that means what? You write here you have to take modulus of x minus 3 less than or equal to 5 only you take. But take here x not equal to 3 take here. Why? Because if I take x is equal to 3, we are getting a 0 or not. But it never equal to 0 here. If 0 equality is there, then we consider 0 part also. But here equality is not there means that modulus never became a 0. So when modulus is becoming a 0, for 3 it is 0. That's why the 3 part I am eliminating it. Now again it is look like a which form? Modulus of x less than or equal to a form or not. So you write down minus 5 less than or equal to x minus 3 less than or equal to 6. Adding 3 on both sides, add 3 on both sides, we have to do it. Then what happened? Minus 2 less than or equal to x less than or equal to 8. But between minus 2 to 8, 3 is there or not? Between minus 2 to 8, what is there? 3 is there. It should be a eliminate or not. Why? For 3 we are getting a 0. Actually 0 is not necessary. So, and x is not equal to 3. So therefore solution set what happened? Therefore solution set is x belongs to minus 2 also considering, 8 also considering. That's why minus 2 comma 8. But between minus 2 to 8 which is there? 3 is there or not? So that, but 3 actually we should not consider here. That's why what I'm going to do here, I'm eliminating a 3 or not. Okay, ma, next question. Modulus of x minus 3 greater than 2. Modulus of x minus 3 greater than or equal to 2. So this is also look like a which form? Modulus of x greater than or equal to a form. So it implies what x plus whatever is there, that is x minus 3, x plus what is there? X minus 3. So this implies what? X less than or equal to minus a, or x is greater than or equal to a or not. So this is less than or equal to minus 2 or greater than or equal to 2 or not. So it implies what? X is less than or equal to 1 or not. So minus 3, or x is what? Greater than or equal to 5. So therefore solution set is what? Therefore solution set is what here? X belongs to minus infinite to what is here? 1 or not. Union, whenever R is there, you take a union or not. 5 to infinite. R means union. So add the solutions. And means commonality of the thing. R means union of the results. And means commonality of the results. Next here, question number 7. Whole modulus of mod x minus 1 minus 2 less than 5. How it is illustrated here? The solution of this is that this is the modulus. So again you consider this total as a x. So then mod x lies between where to where? Minus 5 less than modulus of x minus 1 minus 2 less than what? 5 or not. Why? This total I consider as what? X. So mod x less than 5 means minus 5 to plus 5. It implies add a 2 minus 3 less than modulus of x minus 1 less than what? 7 or not. But minus 3 to 7 we have which values? Negative values, 0 and positive values or not. Minus 3 to plus 7 we have negative values, 0 and positive values are there. But we want to consider, we are solving with modulus function. That's why we have to consider only 0 and positive values are there. Should not consider negative value. So finally it became a what? 0 less than or equal to mod x minus 1 less than 7 or not. But here 0 equality is there or not? So equality is there means 0 also should consider. When it is a 0, it is a 0 when x is equal to 1, modulus of x minus 1 is what? 0. So this x is equal to 1 also should consider here or not. Actually by solving it we got a negative to positive value. Between negative to positive value we have a negative values 0 and positive value. But dealing with a modulus function, we consider only a 0 and a positive value, should not negative value. So now it implies what? Already you got an idea that we should include a 0 part. So that is x is equal to 1 should include here. Now you solve it. Leave it this part just to focus on this one. Modulus of x minus 1 is what? Less than 7. Why leave this part? Already we consider 1 here, 0 also consider. Remaining things are what we have to do here. x minus 1, this x minus 1 less than 7. So that implies what? Minus 7 less than x minus 1 less than plus 7. Add 1, minus 6 less than x less than 8. But just to look at here, in this x is equal to 1 is there or not, to check it up. X is equal to 1 is there, no need to add it. Is not there, you must add it on. Add it means you take in a union. Between minus 6 to 8, 1 is there or not, so no problem. Therefore solution set is what? Therefore solution set is what? X belongs to minus 6 comma 8. Next, similarly look at here. Whole modulus of mod x minus 3 less than 1. Sorry, mod x minus 3 greater than 1. Whole modulus of mod x minus 3 greater than 1. So then what happened, you see here. Again you consider this total as what? X. Then it is look like a which form? Mod x greater than 1 form. So that implies what? X is less than minus 1 or modulus of x or modulus of x minus 3 greater than 1 or not, formula. As you know that it is a which value? So what is given here? Modulus of x minus 3 less than minus 1. So that implies what? Modulus of x less than the modulus of x minus 3 less than minus 1. Minus 3 shifted to that side. 3 minus 1 is what? 2. Or modulus of x is what? Greater than 4 or not. So it implies what? Mod x less than 2 means x is lies between where to where? Minus 2 to 2. Or mod x greater than 4 means what? X less than minus 4 or x greater than 4. Therefore solution set is, whenever the what are here, in between what are their connecting words? In between the connecting words are what here? The connecting words are R or not? Connecting words are R. So R means you take a union of the solutions on. So therefore x belongs to what? Order wise. X less than minus 4 comes first. That is minus infinite to minus 4. Union. Next this will come minus 2 to 2. Next which will come 4 to infinity. This is your solution set. Now question number 9 you look at here. Already we did this kind of problem. Question number 9. Modulus of 2x minus 3 plus modulus of x minus 1 is equal to what? Modulus of x minus 2. Modulus of 2x minus 3 plus modulus of x minus 1 is equal to what? Modulus of x minus 2. So that's why what we have to do here, same solution. Modulus of 2x minus 3 plus modulus of x minus 1, okay, this is equal to This inside the modulus, this inside the modulus, try to write in terms of these two only. This inside the modulus, try to write in terms of these two or not. In terms of these two. How I can write, you tell? I can write as 2x plus 3 minus x minus 1 or not. How I write? 2x plus 3 minus x minus 1. 2x minus 3, sorry. 2x minus 3 minus of what? X minus 1. Can I write like this? Then what happened? 2x minus x is a x, minus 3 plus 1 is a minus 2. Now clearly if you observe this, it is look like a which form? Modulus of x minus y is equal to mod x plus mod y form or not. Modulus of x minus y is equal to what? Mod x plus mod y form is there or not? Then what mod x minus y is equal to mod x plus mod y form. Then what happened? Here sign is a negative, here sign is what? Positive. Both has a opposite sign or not? Both has a opposite sign means what I said to you yesterday. It should be what? Xy is less than or equal to 0 or not. What is xy here? 2x minus 3 into x minus 1 less than or equal to 0. ఇక్కడ నుంచి 2 కామన్ తీస్తే x minus 3 by 2 into x minus 1 less than or equal to 0. But 2 I take a common here. Here I have taken a 2 common. The 2 taken common. That implies what here? X minus 3 by 2 into x minus 1 less than or equal to 0 only I have written. Why? This is the 2 which is a positive value shifted to other side. 0 by 2 it became a 0. But because of positive value is shifted to other side, inequality is not changed. If negative value is shifted to other side, certainly inequality will change. Only positive value is shifted to other side. That's why inequality is not changed. Now I already told you that x minus alpha into x minus beta less than or equal to 0 and alpha is less than beta. That implies x is lies between where to where? Alpha to beta or not. So according to that, here is what happened. 1 less than or equal to x less than or equal to 3 by 2 or not. But try to write down this format. Right hand side format is in terms of a left hand side format. Is possible or not? Try to write it. If it is possible, you do it. Later I compare it. It is a look like a which form? Modulus of x minus y is equal to mod x plus mod y. So xy is what? Obviously less than or equal to 0. Why? I have already told you that here sign is a negative, here sign is a positive means both are opposite signs or not. Both are opposite signs means you must take xy is less than or equal to 0. Both are same signs, you must take xy is greater than or equal to 0. Same signs greater than or equal to 0. Opposite signs you take xy is less than or equal to 0. Right, Amma? Next question. Here also see the modulus of x plus 1 by x plus modulus of x plus 1 is equal to what is here, x plus 1 whole square by what, modulus of x is given to you. So solution of this question is modulus of x plus 1 by x plus modulus of x plus 1. Now try to write this as what? I can try to write down this way, x plus 1 whole square by mod x. Can I write down mod x plus 1 whole square by mod x on? Now just look at here, it is a whole modulus of x plus 1 whole square by x. Can I write on? Why? Mod x by mod y can be written as what? Modulus of x by y. Try to write down this inside is in terms of these two. How I can write down here? See, x plus 1 into what? X plus 1 by x n. That can also be written as what? Modulus of x plus 1 into, it is a 1 by 1 plus x corner. But it is a x plus 1 by x means what? Take term wise, x by x is a 1 plus 1 by x. That is modulus of x plus 1 plus what? Inside write it, x plus 1 by x n. Now first this is a mod x by mod y. I written as what? Modulus of x by y. Later I written like this. Later I have written x plus 1, x plus 1 by x. Take term wise here, 1 plus 1 by x. Now you write this is inside. I am getting like this. But here it is used what? X plus 1 by x plus modulus of what? X plus 1 on. Now it is look like a which form? Mod x plus mod y is equal to modulus of x plus y form or not. It look like a which form? Mod x plus mod y is equal to what? Modulus of x plus y form or not. Mod x plus mod y is equal to modulus of x plus y form. So that implies what here? It implies what? Xy is greater than or equal to 0. So that implies x plus 1 by x into x plus 1 is what? Greater than or equal to 0. It implies what? X plus 1 whole square by x greater than or equal to 0. Now as you aware of it, that implies what? This should be a what? Positive and 0. This should be what? Greater than or equal to 0 means what? Positive and 0. This is always greater than or equal to 0 or not. So that implies, see here, again I am writing here, x plus 1 whole square by what? X greater than or equal to 0. This should satisfy it. But it is a square term or not. Square term is always what? Greater than or equal to 0. Square term is always greater than or equal to 0. So that is not problem. But the problem is what? Denominator. If denominator is a negative, it became a less than or equal to 0 or that. If denominator is a negative, it became a less than or equal to 0. If denominator is a positive, certainly it became a what? greater than or equal to 0. So that implies what here? X should be a greater than 0 and x is also equal to minus 1 or not. Why? If I take x is equal to minus 1, then only it is equal to 0 or not. Because here 0 also consider and positive also consider. X plus 1 whole square is a 0 as well positive. That's why 0 for minus 1 and positive for any other value or not. Positive for any other value. But here is what? X greater than 0 and x is equal to minus 1 only you consider here. So that implies what? Therefore, the solution set is what? This is true for every value of x. That is not necessary to us. This is a positive for x belongs to R. This is greater than or equal to 0 for every x belongs to R. But this is a positive if what? X greater than 0. Therefore, the solution set is what? These two common value are not. CM, numerator is always greater than or equal to 0. Numerator always greater than or equal to 0 for all x belongs to R or not. For all x belongs to R. But denominator is a positive only for x greater than 0. Since the inequality is a hold when denominator is greater than 0. But numerator is obviously greater than or equal to 0 for all x belongs to R. But the only fact here is what? The denominator should become a greater than 0. So that is x should become a 0. And this is what x for all x belongs to R, that is greater than or equal to 0. X greater than 0, this is positive. So finally, combine these two. We have to take a common value on. What is that common value? X greater than 0 is only our common value. Therefore, solution set is what? X belongs to 0 to infinite. But to that, you must also add minus 1 or not. Why? For us, the inequality should be a positive and the inequality should be 0 or not. Inequality is a positive and inequality should be 0 means when inequality is 0, minus 1 value or not. That's why I added a minus 1 here. Okay, tomorrow we are going to start a very important method, that is the wavy curve method. Wavy curve method.